Hey students, if you would like to see some more examples of how to evaluate expressions using properties of exponents, then this is the video for you. I'm going to take a quick moment and show you some special cases and some more examples. So here we go. This first problem, we actually have two sets of factors. We have tens, we have two tens, and we have two fours. And so we can't just combine those together and say we have four of some factor. We actually have to treat them separate, right? And so we just go ahead and expand them out like we've done. We can use this funnel method and say, well, 4 times 4 is 16, and 10 times 10 is 100, and then 100 times 16, that would actually take and add 2 zeros on the end of the 16. That should be 1600. Let's look for another problem. Okay, students, in this problem, we actually see negative exponents. And if you don't know what negative exponents are about, if you've kind of just memorized something somebody told you, but you forgot it, and it's kind of sand that's disappeared, then you should go back and watch the videos where I explain that, how to multiply and divide with exponents. They're topics F8 through F10 if you're using the IXL labeled videos. But for this problem, let's go ahead and take a look and assume you've already discovered the y, and we're going to reference that the negative exponents are unhappy. Okay, so in this first problem, what we're seeing here is that we have two nines, but instead of repeatedly being multiplied in the numerator, they're actually being repeatedly divided. That's what the negative sign kind of tells us, that they're not where they belong. They're homesick. They're not where they belong. So their home is where? The other side of the fraction. Okay, so if we rewrite these on the other side of the fraction, we'd actually end up with 9 to the second power on the bottom of the fraction. And now we can take a look at the other ones. We have another one factor of 10. It's not where it belongs, so let's move it. Okay, it gets moved to the bottom. And now what's left on top? If nothing else is there, it's actually that there's just a factor of 1 there. Okay, so now we can reduce this and we'd say we have 1 over, let's see, 9 times 9, that would be 81. And then 81 times 10 would be 810. Let's go for another example. Okay, for this last example, we're going to rewrite everything where it belongs on the fraction and make all the exponents positives. Okay, so making those exponents positive, I'm going to go ahead and circle everything that is staying where it belongs. I'm going to mark those in pink. So 11 to the third, 11 to the seventh, those are staying where they belong. Now let's mark where the ones that need to move go. Okay, now let's mark where the negative exponents are, and we'll make a note that they need to move. Okay, the 11 to the negative 9 is going to move to the bottom, so it'd become 11 to the positive 9. Hey, he's home. He's not homesick anymore. He's where he belongs. And now, before we go multiplying all these out, let's go ahead and reduce what we can. Okay, on reducing these, what I notice is if we were to expand all these out, I'm going to think of that in my mind because that would take a long time to write. We would actually get 3 and 7. We'd have 3 plus 7. We'd have 10 of those 11s on top of the fraction. Okay, now on the bottom, we still have 9 of the 11s. And now let's reduce. Okay, to reduce these, we actually just want to picture those expanded out. There'd be 10 of the 11s, 9 of the 11s. 9 of them would cancel. There'd be no more on the bottom. And if 9 of them canceled, there'd be how many left on top? Uno. Not too bad. Our final answer was very easy to calculate. All right. Hey, great job on this topic. If you guys need any more help, don't be afraid to write a comment and ask questions. I'd love to help you guys out. All right. Take care. Love you guys. Bye-bye.